Now in trigonometry there is a very important chapter, that is periodicity and extreme values. So in this first point is, what is the meaning of periodic functions? A real function, f from a to r is said to be a periodic function, if there exists a positive real number p such that f of x plus p must be equal to f of x. For all x belonging to a. Least value of p is known as the fundamental period of f. Least value of p is known as fundamental period of f. Now for example, if the given function is sin x, here if fx is sin x, since sine of x plus 2 pi is always equal to sin x, therefore period of sin x is 2 pi, because 2 pi is the least positive real number for which sine of x plus 2 pi is always equal to sin x. Therefore, period of sin x is always 2 pi. Similarly, if fx is equal to cos x, since cos of x plus 2 pi is also equal to cos x, therefore period of cos x is 2 pi. If fx is equal to tan x, since tan of x plus pi is equal to tan x, therefore period of tan x is pi. Now there are few important results. First one is the period of f, if it is p, then period of f of ax plus b is P by mod A. If period of f, if it is P, period of f of Ax plus B will be P by mod A. Now for example, period of sine function, period of sin x is 2 pi. Therefore, period of sine of Ax plus B is equal to 2 pi by mod A. One more example, period of sine of 2x plus 5 is 2 pi by 2 mod 2, which is 2. Therefore, it will be pi. Therefore, if period of f, if it is P, period of f of Ax plus B will be P by mod A. This is first result. Second result here is let gx be equal to c1 f1x plus c2 f2x divided by c3 f3x plus c4 f4x, where f1, f2, f3, f4 are trigonometric functions. They are what? Trigonometric functions. Okay, they are trigonometric functions. And c1, c2, c3, c4, they are constants. They are constants. Then the period of gx, then the period of gx is LCM of period of gx is LCM of period of f1, f2, f3, f4. For example, if gx is equal to sine 2x plus 3 tan x divided by cos x plus 4 cot x, then period of gx is LCM of the period of sin 2x, tan x, cos x, cot x. Therefore, period of sin 2x is pi, period of tan x is pi, period of cos x is 2 pi, period of cot x is pi. Therefore, its LCM will be 2 pi. So, therefore, the period of gx will be 2 pi. Important note points. If P and Q are rational quantities, then LCM of P and Q exists. LCM of P and Q exists. First point in this note. Now second point here is, if P and Q are irrational, are irrational. Then LCM of P and Q does not exist. Does not exist unless they have same irrational, unless and until they have same irrational surd. Very important point. If P and Q are rational quantity, then LCM of P and Q exists. But if P and Q are irrational, LCM of P and Q does not exist unless they have same irrational surd. Third important point in this is LCM of rational and irrational is not possible. LCM of rational and irrational is not possible. And in this, fourth point is LCM of A by B, C by D, E by F. If they ask you what is LCM of these three numbers, it is equal to LCM of ACE divided by GCD of BDF. GCD of BDF. Now next result is if f is a periodic function. If f is a periodic function with fundamental period P, then f and 1 by f are also periodic. With period P. One more important result here is a constant function is a periodic function. Constant function is a periodic function, but does not have a fundamental period. Does not have a fundamental period. One important note point here is what is the period of fractional part of x? What is the period of fractional part of x? Fractional part of x actually means x minus step x. Period of fractional part of x, which is x minus step x, is always 1. Period of fractional part of x is always equal to 1. Now let us write some standard results. First one, period of mod sin x, mod cos x, mod tan x, mod secant x, mod cosecant x. Period of all these 6 functions is pi. Very important point. Second one, period of mod sin x plus mod cos x. Mod tan x plus mod cot x is always pi by 2. Is always pi by 2. Third standard result is period of mod of sin x plus cos x. Mod of sin x minus cos x is pi. Fourth standard result is period of mod of tan x plus cot x, mod of tan x minus cot x is pi. Fifth standard result is fifth one, if n belongs to z plus, n is a positive integer, then period of sine to the power of 2nx plus cos to the power of 2nx secant to the power of 2nx plus cosecant to the power of 2nx tan to the power of 2nx plus cot to the power of 2nx is pi by 2. Is always pi by 2. Maximum and minimum values Now first point here is maximum value of sin x is always 1. Minimum value of sin x is minus 1. Therefore, range of sin x is closed interval minus 1 to plus 1. Second point here is maximum value of cos x is 1. Minimum value of cos x is minus 1. Therefore, again, range of cos x is closed interval minus 1 to plus 1. The third point, very, very important, minimum value of a cos x plus b sin x plus c is equal to c minus root of a square plus b square. c minus root of a square plus b square. Maximum value of a cos x plus b sin x plus c is equal to c plus root of a square plus b square. Therefore, range of a cos x plus b sin x plus c is equal to closed interval c minus root of a square plus b square, c plus root of a square plus b square. Now for example, range of three cos x plus 4 sin x plus 5. Range of 3 cos x plus 4 sin x plus 5 will be equal to 5 minus root of 3 square plus 4 square, 5 plus root of 3 square plus 4 square, which is equal to 5 minus 3 square plus 4 square under root again becomes 5. This will be 5 plus 5. Therefore, range of this function is 0, 10 closed interval. Now the next point here is very important result actually. The minimum value of a square sin square theta plus b square cosecant square theta is 2ab. Now small proof of this is, now since arithmetic mean of two positive real number is always greater than or equal to geometric mean, therefore arithmetic mean of a square sin square theta and b square cosecant square theta is a square sin square theta plus b square cosecant square theta by 2, and geometric mean is under root of a square sin square theta into b square cosecant square theta. So therefore, if arithmetic mean is greater than or equal to geometric mean, it implies a square sin square theta plus b square cosecant square theta is greater than or equal to, cross multiplying, it becomes 2 sin square theta cosecant square theta, when multiplied it becomes 1, root of a square b square becomes ab. Therefore, minimum value becomes 2ab. Minimum value is 2ab. Similarly, minimum value of a square cos square theta plus b square secant square theta is 2ab, and minimum value of a square tan theta plus b square cot theta is also 2ab. So these are few very important points related with periodicity and extreme values.